So welcome. We are now in week 5, lecture number 9 of Math 140 Science. And we are starting today after skipping chapters 6 and 7, at least for now. We are starting chapter 8 on producing data via sampling. So up until now, we never really asked the question about where data comes from. We just kind of said, oh, you have the sample, and what's the mean, and what's the variance, and what's this, and what's that. Okay, I'll change the attendance here. So where does data come from? Well, it starts with the underlying population. If I'm taking, yeah, question?
Are you gonna share your screen, like your tablet?
That might help. That might help if I did that, wouldn't it? Okay. Okay. So that might help. Is that better? No, I'm still not sharing. Share. Only I can, okay. Share. Okay, so chapter 8, producing data via sampling. And we're gonna, it all comes from the underlying population, which is the entire group of individuals about which we want information. So for example, if I'm really interested in who's going to win the up and coming election, or maybe historically who, if I ask myself prior to the election, who's going to win? Is it going to be Trump or Biden? Who's going to win? Well, one thing I can do, of course, is I could ask every single voter who they're going to vote for and make a tally and get the numbers, and oh, there's my answer, which is of course not practical for many reasons. People lie. There's too many people to ask. Not everyone votes, even those who say they're going to vote. Could be many reasons why that might not be feasible. But the fact is that the population of individuals about which we want information in this example are all voters. I don't care what children say. I don't care what people in Zimbabwe say. All I care about are the voters themselves, people who are going to vote. That is the population about which I care about. Of course, I'm not going to ask all of them. So what do? I take a sample. It's a part of the population. Now, it could be a very big sample. How big? In theory, I can ask everyone. I could, in theory, get the entire population and have a huge sample. And usually it's, of course, a lot smaller. And we use the sample to draw conclusions about the population. Do I really care what the average of my sample is? No. I'm using the average of my sample to determine what the average of the population might be. That's what I care about. If I want the average height of every CSUN students, I might take this class and average all of you guys, because you guys are representative. It's not like this is a tall people only register for this class. You're just random people. But do I care that the average of this class is 5'7"? Only in the sense that that average will help me to draw conclusions about the average for the entire population. So in general, I don't care about samples, but I do care about samples in the sense that they allow me to predict things about the population. And that's what I really care about. and how we use the sample to predict things about the population, well, that is, of course, what statistics is all about. The displaying data and sampling and visualizing, all that stuff is wonderful. But for me, the best part about statistics is saying, okay, here's what I have. What am I allowed to infer from this? And we do that via what's called a sampling design. Well, I guess I misspoke. The inference comes later. The sampling design is the method by which you pick a sample. So every sample is chosen in some way. So the method of how a sample is chosen. For example, what are some possible ways of picking a sample of CSUN students? What are some possible ways? If I want a sample of 100 CSUN,
a random sampling or random.
well, I don't know about this word random sample yet. That's too advanced for me. I don't know what that is yet. I'm just looking for different ways of picking a sample of students. So someone said by major. What do you mean by that, by major? What does by major mean in terms of picking a sample? Be more specific, because it can mean multiple things. Anyway, I want 100 random seats. Okay, picking students around campus like a survey. So, but how would you pick the students? What is the, by A, how many people have that? How many, but again, you guys are not answering my question. I want to pick 100 people and ask them something. Somehow I have to choose you and you and you and you. How am I picking those specific 100 people? What is my method for the specific people that I choose? If you say by race, you're saying I'm going to choose everyone of a certain race. Is that what you mean? Or by major, every one of a certain major? Is that what you mean? But what does by year mean? I'm thinking of every freshman, every sophomore. Is that what you mean by picking a sample? Convenience. Okay, you're already using a term that we know, but I'm asking us a more basic question. Again, guys, this doesn't answer my question. How would you have a clipboard? You're going out and you want to ask people, how do you pick them? How do you decide who you're picking? Don't give me this fancy statistical term. Just tell me in layman words. How do you pick them? Here, I'll give you an example. Okay, whoever comes up to you, fine. You have a table. The table says, I'm looking to take a sample. Please stop by. I want you to fill out this questionnaire. Whoever walks up to you, perfectly valid way, not saying it's a good way, but perfectly valid way of generating a sample. Here's another one. I will stand by the doors of the library, and every 10th person who walks by, I will stop and say, excuse me, sir or ma'am, can you answer this question? That is a method of picking people. What I'm looking for now are other methods of picking people that are different. So I have whoever comes up to you, that's perfectly valid. Me picking every 10th person who walks by a specific spot. It's a very specific way of choosing people. Can anyone think of anything else? Whether it's good or bad, can you think of another way of picking a sample from the university? Everyone who walks out of the bathroom. So a specific bathroom. You're going to go by, you're going to find a specific bathroom and walk and ask people as they come out. Okay. That's perfectly fine. Assuming you have a specific person. How many people enter the gym on Fridays? What do you mean by asking a question? How many people enter the gym on Fridays? What does that mean? You're asking a question. How does that tell me which people I'm asking? But what Mary said, choosing a person from each class. So you mean going down the roster of math 100, math 101, math 102, chemistry 101, chemistry 102, etc., somehow getting into the school registration system and picking one person from each class. Is that what you're saying, Mary? Perfectly fine. Perfectly valid way. Whoever has blonde hair coming in and out of the gym. Okay. Perfectly valid way. Choosing people who went to the gym on Fridays. So you walk to the gym on Fridays and anyone who walks in. Perfectly valid way. There's many ways of picking a sample. Some of them are better than others. The sampling design is just merely a sentence, a paragraph, explaining how you are coming up with your sample. It is not mathematical. It is just a description. Where the sample is coming from, we call that the sampling design. Now, some designs are better than others. For example, I'm curious what everyone's favorite sport is. I really love sports, and I'm curious. I know my favorite sport, and I'm wondering what's everyone else's favorite sport. So here's what I'm going to do. I'm going to go to the next Lakers game, and I'm going to ask everyone I see at the Lakers game what your favorite sport is. Do you think that is a valid sampling design?
No.
Why not? I didn't say it's a good one, but it's valid. Why is it that's fine. I didn't say it's a good sampling design. I just asked, is it a sampling design? Have I described very succinctly and very clearly how I'm going to get my sample? Yes, it's a perfectly valid sampling design. Now, is it a good sampling design? It's a whole other question. No, it's a horrible sampling design. Right? Because as people say, they already know this term biased. It's biased. I'm more likely to get one result than another. Okay, suppose I'm interested in how tall people are. So I am going to go to the next year's graduation ceremony. And as every third person walks down the aisle to graduate, I will quickly ask them, hey, how tall are you? And I'm going to ask 500 people how tall they are by asking every third person. Is that a valid sampling design? Do you think it'll give me a result representative of the average CSUN student? Why not? It's not like flower, you say no, why not? Are people arranged by height?
Because you're not if it's average, then you're not choosing everybody, you're choosing every third person.
I understand, but there's no way that I can get everyone. That takes too much time, that takes too much energy. The whole point of a sample is to use my sample to infer information about the entire population. Would 500 people, would the average of 500 be reasonable to be close to the true average, whatever it is? Yes. In that case, okay, if it's reasonable to assume that the result of my sample is somewhere in the vicinity of the true results, I would like that sampling design. But at the end of the day, a sampling design is just a method of getting data. Okay, so what are some various sampling designs? And as we go through them, we'll kind of think a little bit about whether or not the designs are good or bad and why they might be good and why they might be bad and things of that nature. So the first one the book mentions is called a survey. Okay. Well, it's not really a sampling design, but I guess, okay, maybe that was phrased poorly. Let me first just define what a survey is, okay? A survey is just a list of questions asked to each member of a sample. Again, to infer information about the population. So it's not a sampling design. It's just a definition. Okay, what exactly is a survey? So we have these definitions. And now the question is, how do we sample badly? So section 8.2, section 8.1, by the way, was titled just, I'll put it here, population versus sample. Population versus sample. 8.2 is labeled how to sample badly. And I heard this term already a few times today, how to sample badly, this term bias. A study is biased if it systematically favors certain outcomes. It's not always obvious how to tell if a study is biased. Sometimes, like the basketball example, it's obvious that it's biased. But what exactly makes it obvious? It's kind of hard to put your finger on it. Well, you can say, well, people who go to a basketball game probably like basketball, and therefore they're naturally favored to like it, and therefore it might be their favorite sport. So how do you mathematize that into bias? You can't really do it. It's just a feeling that you get. But there are times, more sophisticated examples that we're not going to worry about, where you can actually mathematically determine whether or not there's bias. Okay? And I might bring it up one time this semester. There's one example offhand that I can think of where it might come up, but for the most part, we're going to keep it very just intuitive as this feeling of bias. So here's the first bad sampling design. It is called a voluntary response sample. A voluntary response sample. What do you think, just by its very name, what do you think a voluntary response sample is? What do you think a voluntary response sample is?
People who just volunteer to give you an answer?
Yes, people just volunteer to give you an answer. Anyone think of an example? Have you ever come across a voluntary response survey or been asked to, well, you wouldn't be asked to participate in a voluntary response sample because you are voluntarily giving your response. But can anyone think of an example where you might have done that?
When you watch YouTube, sometimes an ad pops up that says, which one of these have you seen? And then you pick it.
Awesome. Awesome. Or even just YouTube in general. You ever read the comments on a YouTube or Yahoo or one of these sites? Who are the people who are most likely to make a comment on something? If you comment on something, it probably means one of two things. What are those two things? Subscriber. Oh, okay, hater, or you're interested, right? Either you love it or you hate it, or you agree or disagree. But if you're kind of a meh, if you're kind of like, I don't care, you probably just move on and don't waste your time, right? You ever read you're on some website and a poll pops up and you're like, I couldn't care less, and you just don't do anything. So voluntary response samples are limited to people who voluntarily respond. They're the ones who walk up to you and say, oh, here's my opinion on this. Well, that was one person sampling. The very first person who got a sampling design right today. I forgot who it was, but someone said people walk up to you at a table or wherever it was. It's a horrible sampling design because it's very likely to be biased. Why is it very likely to be biased? Because only people who are really, really interested in the subject, either they love it or they hate it, are probably going to be the ones who respond. And it's not really representative across the spectrum, right? So It's biased, oops, it's biased because people with strong opinions, one way or the other, are most likely to respond. Does that make sense? Yes? So voluntary response samples are the worst. If you ever need to take a sample for a psychology class or whatever class you're doing, don't do voluntary response. It is inherently biased. Section 8.3, simple random samples. As a general rule, a simple random sample is the best method of creating a sample. Okay, a simple random sample, often abbreviated an SRS. Okay, an SRS, a simple random sample. What is a simple random sample? Well, suppose you have 20 people in a classroom. Oh, better yet, suppose you have a big classroom, you got 50 people in the classroom. And I want you to imagine a scenario where you are the teacher and you're standing in front of a room of 50 people and you need to pick 3 of them at random. What might you do to pick 3 people at random from a big room of 50 people? What are some things you might do if you have to pick 3 people at random from a room of 30 people? So someone said random number generator, which is a great answer and a wonderful answer, and it's a great thing to do. What I'm actually looking for here is something that's not a great thing to do, but that people might do anyway. Okay, choose the first 3 in the front. Okay, so flower. If you choose the first 3, would you think that you just created a random sample? No, right? What does the word random mean? And this goes for everyone. What do you think the word random means in this context? Anyone?
They all have equal chances of getting picked.
Okay, everyone has an equal chance of getting picked. Purely random means no one should be any more likely than anyone else to be picked. So question, if I walk up into the room and I say, okay, I need 3 people, and I point to the right side of the room and I say, okay, you. And then I point to the center of the room and I say, okay, you. And then I point to the left and I say, okay, you. Is that a random sample? Did everyone have an equal chance of being picked? Yes, everyone did. However, it's not a simple random sample. To be a simple random sample is more than everyone having an equal chance of being picked. To be a simple random sample, an SRS requires that every possible group of size n from the population, in this case, size 3 from the room, every possible group of size n from the population has an equal chance of being chosen. So why is it that my example of 1 person from this area, 1 person from this area, and 1 person from this area does not satisfy being an SRS? What fails being an SRS in that example? This goes for everyone, right? What fails being an SRS in that scenario? Where I pick one person from the right, one person from the center, one person from the left. The different locations being chosen from, not everyone can participate because you are choosing them. Well, no, I mean, everyone can participate. If I do one, okay, maybe I'll refine it. In this area here, I'll put everyone's name in a hat and pick one. This area here, I'll put everyone's name in a hat and pick one. This area here, I'll put everyone's name in a hat and pick one. So everyone has a chance of being chosen equally, assuming it's, divisible by 3 or the same size groups. But is it possible that I'm going to get 3 people next to each other? No, it is a whole population. This example, the room is my population. The 51 people in my room, that's my population. I'm picking 3 of them. I want 3 of them at random. One of these 17, one of these 17, one of these 17. Everyone has a 1 in 17 chance of being chosen. What makes it not an SRS is that it will never happen that I will have 3 people sitting next to each other being chosen. It's always going to be one from here, and one here. But to be an SRS means if I want to pick groups of size 3, any 3 people in the room can be chosen just as equally as any other group of 3. And by splitting it up, I will never have 3 people sit next to each other being chosen. If I put everyone's name in a hat and I mix it all up and I pick out 3, could it be any 3 people in the room? Are they equally likely to be picked as anyone else? That's an SRS. That's a simple random sample. So the simplest way to get a simple random sample, the simplest way, no pun intended, the simplest way to get an SRS is to use a random number generator. Everyone know what a random number generator is? So if there's 51 people, I will assign everyone a number from 1 to 51. And then I will go to my computer and say, computer, pick a random number from 1 to 51. And my computer will randomly pick one. Any number from 1 to 51 is equally likely to be picked as any other number. That's an SR. That's a random number generator. If I say pick 3 numbers at random, could I get 1, 2, 3? Is 1, 2, 3 a possibility for a number from 1 to 51? Yeah. Is it likely that 1, 2, 3 will be picked? No, but it's as likely to get 1, 2, 3 as any other 3 numbers. You ever buy a lottery ticket? You ever pick your own numbers for the lottery ticket? You never have? Has anyone here ever bought a lottery ticket and picked their own numbers? You guys are all too young? Could you guys not buy lottery tickets?
My
I'm not sure.
parents have.
Okay, your parents have. When you pick your own numbers, you ever pick numbers next to each other? Do you say, oh, I better not pick them next to each other. That's never going to happen. They're likely to be spaced apart. So I'm going to pick 17 and 31 and 2. Is that what you guys do? I think that's what most people do. But the truth is 1, 2, 3, 4, 5 is just as likely to be picked as anything else. It's just any particular number is like 1 in like 26 gazillion chance of happening, that chances are whatever's picked will look like the numbers are random. But the truth is any 5 numbers is as equally likely to be picked as any other 5. So 1, 2, 3, 4, 5 is as equally likely as anything else. Does that make sense for what a random number generator is and how to use it to get an SRS, a simple random sample? I hope so. This chapter is very qualitative, no math in it. It's just different designs for getting samples, no math. Section 8.4 is called trustworthiness trustworthiness of inference from samples. In other words, you took a sample. I would like to infer something about the entire population about it. Am I allowed to? For example, I'm really interested in who's going to win the next election. Let's say I asked this a year ago. I'm really interested. Is it going to be Trump or is it going to be Biden? My life depends upon this. I really want to know. So I asked 5 people what they're going to vote for. And 3 of them say Trump and 2 say Biden. Do I then say, yes, Trump's going to win? I know it's because the majority voted for him in my sample. Does that seem reasonable? Why not? 3-2, right? Why is it not? Why am I not likely to infer from, it's a small sample. It's a small sample. Okay, one of the big things about sampling is that the larger the sample size, the more trustworthy the inference can be. And as we go on in the course and we get to the more mathematical aspects of it, which is coming up in a few chapters, we're going to learn about exactly how big it has to be to make sure that certain things occur. And when I say exactly how big, I'm talking about to the number. 972 people is what you need. Not 971, but 972. We're going to learn exactly how to calculate specific numbers for various scenarios. But in general, the idea is the bigger the sample, the more trustworthy. That's one of the big ones. Okay, now it's not just the size of the sample that matters. Okay, the sampling design also matters. If you have bias, can you trust the outcome of your sample? Everyone, if you have bias, can you trust the outcome? No, so sample size is not the only factor, right? Biasness is bad as well. So randomness, the more randomness you have, the more trustworthy. We don't only want a big sample, but we really want randomness. Okay, if there's bias, that takes away from the randomness. Does that make sense? So section 8.4 is literally 1, 2, 3, 4, 5, 6, 7 paragraphs long. It's a very small section. And it basically says is we don't want bias and we want large samples. Those 2 things make you trust the inference. Bigger samples, more randomness. So now 8.5. Other sampling designs. We have voluntary response. We don't like that one. My device shut down on me and I was having trouble looking at it, but I'm back. Welcome back. Okay. So other sampling designs. We have so far voluntary response sample. Those were bad. And then we had an SRS. Those were good. So what are some other ones out there? Well, we have one called a stratified random sample. And there are times that a stratified random sample is preferred more than an SRS. A stratified random sample is essentially 2 parts. 2 parts. First, divide the entire population into groups of similar characteristics called strata. Then choose an SRS from each stratum. This Latin endings from each stratum. And that is your stratified random sample. Can anyone think of an example where you might, well, an example of dividing the population into groups of similar characteristics? Can anyone think of some situations where you might do that? Any naturally occurring strata out there in the universe that you can conceivably divide up a population into smaller groups? Think of any?
By country or continent?
Okay. By country or continent or state? Anything else?
By age,
By age? By gender?
Yeah, I was gonna say gender.
By income level?
By ethnicity
By ethnicity
or religion.
or religion? There could be many reasons why you might feel, for whatever particular study you are doing, that it's preferable to by language, like first language that you speak. English, native English speakers, native Spanish speakers, native, Mandarin speakers, and so on. There could be many reasons. So a stratified random sample is just one type of sample. It's kind of like an SRS, but with this extra kick to it. Here's another one, which I didn't see in the book when I read through it, but it's an important one that you should know. It's called a cluster random sample. And on the surface, a cluster random sample looks very similar to a stratified random sample. They look very, very similar, but there's a slight difference between them. First, divide the entire population into groups of similar characteristics. Called clusters. Then, and of course, here's the big difference. In the first case, we divided into groups and then picked a sample from each group. What else might we do besides pick a sample from each group? Whether it's a good idea or a bad idea. What else might we do besides, once we divide them into groups, picking a sample from each group? No, I don't mean how would I go about creating this? I'm saying, besides picking a sample from each group, what's something else that I might do as my follow-up step?
Weigh it based on the percentage that cluster has in the population.
But before we do that, how do I decide which people in the cluster to pick is what I'm saying. I don't have my data yet because I haven't actually taken my sample. I divided the population into smaller groups, but I haven't taken my sample yet. For the stratified random sample is after I divide them into groups, I do an SRS from each group. With the cluster, I'm going to do something else. And the question is, what is that something else that I might do besides take a sample from each one? And the answer is then choose an SRS of clusters. Don't pick from each one. Choose some and take the whole thing. So I might divide up a group of 1,000 people into groups of 10, and then pick 3 of those 10 groups. Sorry, pick 3 of those groups, so I get 30 people. I get the entire cluster. Does that make sense, the difference? Again, in the first case, I mean, here, I'll make a picture here. Maybe I can visualize this better. Here's the population. Come on. Here's the population. I divide the population into groups. That's my first one. That's my second. Why does it not make it straight all the time? So suppose I have 4 strata. Okay, suppose I have 4 strata. Oh, it's not even straight. Okay, I have 4 strata. And suppose there's 3, or let's make it 5 individuals in each strata. Okay, so this is the first one is the stratified, and the second one is going to be the cluster. So this is my stratified, and this is my cluster. Okay, in purple, if I do the stratified, give me an example of taking a sample in the stratified way. I want, for example, I want to end up with 8 elements. How would I end up with 8 elements, 8 individuals in the stratified way?
You take a sample from each strata.
Okay, so I got these 2, I got those 2, I got those 2, and I got those 2. Okay, that is an example of stratified. Now, what's an example in cluster? If I want to get a random sample in cluster, what might I end up with if I do a cluster sample?
Pick 2 random strata.
Yeah, so I might get this whole thing and let's say this whole thing. In the cluster, you take entire clusters, however many you're going to get of them. In this case, 2. It could have been any 2. It happened to be the first and the last. In the stratified one, I look inside of each strata, take 2 randomly, and I do that one for each strata. Does that make sense? The difference between stratified and cluster? Yes, no, maybe so. Anyone?
Yes, but I'm a little confused in that, do the stratas have to have an equal number of people in each group? Because like if you separated people by race and then you only took like Latino and Hispanic, that wouldn't accurately represent the population.
You're right. So let's make it more obvious by putting different numbers in each one. How's that? Is that better?
Yes, but in terms of when you take the entire strata, but like several random entire stratas,
Yeah.
That's the one that make as much sense. Do they have to be an equal number of people in each group?
They do not. They do not. They do not. You just, the way you're choosing them is by groupings rather than internally within each grouping. So in neither case do they have to be the same size. Okay, does that answer your question?
Yes, thank you.
Okay. And by the way, these are examples of what is called multi-stage sampling. In multi-stage sampling, you have various stages. You don't just get your sample in one step, but in this case, you first divide it and then take an SRS from each one, or you first divide it and then take an SRS giving you some of the clusters. Multi-stage sampling has stages, has multiple stages. Okay, so these are examples of multi-stage sampling. Okay, maybe if I was really interested in the election, I wouldn't, maybe I would, you know, if I did an SRS of the entire population without breaking it up into either clusters or strata, maybe I'll get a disproportionate amount from Wyoming, where it has a smaller effect than from California or from New York or from Texas or something like that. So I might want to divide it up into pieces and then do an SRS from each piece or every district. So there's many reasons why I might prefer that than an SRS, a straight up SRS. Do those make sense? Yes, no, maybe so? Those, anyone here? Bueller? Okay. So, section 8.6. Cautions about sample surveys. Cautions about sample surveys. There are two things that might occur for which might lead themselves to bias. One of them is undercoverage. Undercoverage occurs when some part of the population is left out of the sampling design. Can anyone give an example of a situation of undercoverage where I might take a sample and leave out some part of the population? Anyone? Choosing a certain, no, give me a specific example. Give me a specific example of undercoverage. Like, just like I said earlier with the sampling design, I was like very specific. Do this, do this, do this. Give me a specific example of undercoverage where you might do something and leave out a certain part of the population.
Leave out kids because they can't vote from that.
Okay, well, first, Louise said only people with landline phones, right? If I only call landline phones, I would not include anyone of the homeless population, correct? Because they don't have a landline phones. And even I have a house, but I don't have a landline phone, right? I only have a cell phone. So if I get like a phone book or some listing of landline numbers and I use that to make my survey, then I would not include a significant portion of the population. Now, what were you saying? I'm sorry, I didn't mean to interrupt, but what were you saying? Hello? Anyone? I thought someone was talking. And I didn't mean to interrupt you, but someone, okay, whatever. So under coverage is a big one. You got to make sure whatever population you're representing with your sample, that your sample represents them. You can't leave some out. Okay, if I'm curious in the average heights of every CSUN student, and I only ask women, do I expect my answer to be representative of the entire population? No, I'm leaving out a significant portion, right? So sometimes it's obvious under coverage, okay? The other one is non-response. Non-response occurs when an individual for a sample either can't be contacted or chooses not to participate. Can anyone give an example when that might occur, or has it ever occurred to you? Can anyone think of a situation of non-response where a person refuses to participate?
Could this be like voting? Not everybody votes.
Well, but not everyone votes, that's true, but we're talking about a sample. So what non-response in your sample are you talking about? Because if I don't choose to vote and then someone's elected, there was no survey, there was no study done, there's no statistics being done, right? So cell phone surveys, maybe they don't have a cell phone. But that would be under coverage, right? You're not covering people who don't have cell phones.
What about like ethnicity, where you can like put you prefer not to say?
Well, that's an option. I mean, on those surveys, if prefer not to say is an option, that's a perfectly valid option as part of my survey. I'm talking about, you're at the dinner table and the phone rings and someone says, "Hi, I'm calling on behalf of this organization." You're like, not interested, and you hang up. Right? You just choose not to participate because you can't be bothered with it. Right? That's your choice. International status. I don't know what that means. International status. Can you explain? What does that mean, international status? Luis? Like immigrants versus resident or citizen. But again, what exactly is going on? What exactly is happening? What's your sample? What's the sampling design? What's happening?
Wouldn't non-responsive be like the voluntary one?
It would be as bad, because if you're volunteering to respond, you're also volunteering not to, in a sense. Right? You're saying, I'm not interested in helping out. I get them all the time. As a CSUN professor, I get these emails all the time. We're doing this survey on this, people who have taught, this math class, this stats class, we're trying to do this. Would you please participate so we can do this and that? And sometimes I'm like, you know what? I started, and then it's like, oh my God, this is taking forever. And I just stop. I just don't have the time. Applying for jobs on having to do background. Okay, if the individual in the sample is dead, certainly, right? Sometimes you might create a sample and you went out of your way to make sure that it's a nice random sample. Maybe it's even stratified. We get people here, we get people here, we get people here, and then the guys are dead. Well, they obviously can't participate, so we don't get a representation from that area. I'm applying for jobs. Again, Luis, I'm still not understanding what you're saying. I'm sorry. But if someone has a long job and isn't home, yeah, they're not home. You just can't reach them. No internet to complete the survey. Okay, yeah, it's like, okay, log in to this website, please, and answer these 10 questions. Oh, I don't have the internet, too bad. So you're a certain segment of the population that maybe you would like to get their representation, doesn't have the internet, doesn't have a phone, doesn't have a way of contacting. These are all situations which might lead to bias. These are all bad. Of course, there's even something worse than that. There's response bias. Okay. Response bias occurs when someone answers falsely, intentionally or by accident. Intentionally or by accident. Response bias occurs when someone answers falsely, intentionally or by accident. Obviously, that's going to change things, right? Right? Yes, no? How about this one? Wording bias. Wording bias. Here's an example of wording bias. Ready? Again, I'm prefacing this by saying I'm using this only as an example. I am not stating my own opinion one way or the other. So do not read anything into my wording. It's just an example. But suppose somebody came along and said, I'm taking a survey. Are you pro-abortion? Sorry, are you anti-abortion, or do you like killing babies? You see how the wording of that might make people respond maybe differently than they would have otherwise if it was phrased in a more non-biased fashion? Yes, no? Okay, wording bias, okay, is a real thing. Interviewer bias. Interviewer bias. Here's an example of interviewer bias. Oh, can anyone here? How about you guys first? Can anyone think of an example of what might count as interviewer bias? Can you think of a scenario where the person asking the questions in and of itself already introduces bias into the experiment? Want a certain age. What do you mean by that? If I'm, yeah, so what's an example of just me asking the questions is enough to possibly introduce bias versus somebody else asking the questions?
Could it be like for like politics, how people are wearing, like if they were wearing, or if people doing the interview are wearing pro like Democratic or pro-Republican side, and they're interviewing you and asking you questions about that?
Okay, so maybe you see someone wearing a MAGA hat and you're very anti-Trump, so you're already, inclined just to argue with them on principle or agree with them on principle, depending on what you believe. They're asking a question about themselves. Hey, does this make me look fat? Oh no, never. No, you look wonderful. How about something more delicate? Have you ever been sexually abused? Do you think you might answer differently to a woman versus a man asking? Okay. Do you think reparations are due for slavery? Would you answer differently for a white person versus a black person asking? Right? I'm not saying you necessarily would, but can you imagine a scenario where some of these questions you might answer in a different way depending on who's asking? Right? Do these seem reasonable? Inclining to a certain side type. Yeah, inclining to a certain side type questions. I think my abortion question was that way, right? So, are you anti-abortion or do you like killing babies? Right? It's the question itself. Well, that's the wording. That's the wording. So inclining to a certain side, I think, is more of a wording thing. But I really like the asking questions about themselves things. Because you don't want to be mean. So, oh no, you're a wonderful teacher. You really you're wonderful, Professor Berkowitz. You're fantastic. You're the best. And then we realize what's really going on behind the scenes. Anyways, so any questions on that section on the cautions about sample surveys? And by the way, just so you know, you can take courses in college on just how to sample properly. I mean, we're talking about, we finished it in an hour, the chapter essentially on surveying. You can have an entire course just on surveying. Okay, you can write a paper, your PhD thesis on surveying. I mean, these are not simple topics by any stretch of the imagination. But are there any questions with anything we did so far today? Seems pretty good. Yes, no, maybe so. All right. So that's it for chapter 8. But we're also going to do a little bit of chapter 9. Okay, 9 is a follow-up to 8. Again, not mathematical at all. Chapter 9 is more the same. 9 on is producing data via experiments. Producing data via experiments. Boy. Yeah. Okay. So we're going to start with the following 9.1, which is observation versus experiment. Observation versus experiment. Sometimes you sit down as a statistician and you actually do something to get a result. I am interested in whether talking to plants will make them grow faster. So I will talk to this one an hour a day, I'll talk to this one a half an hour a day, and this one gets a silent treatment, and let's see what happens. Okay, you're actually doing something actively. I'm also interested in if smoking while pregnant harms the babies. So I'm going to make these people smoke a pack a day, and these people half a pack a day, and these people won't smoke at all. Is that a good experiment? You think there's anything ethically wrong with something like that? Assuming that smoking does in fact potentially harm children, I can't really do that, correct? But what I could do is after people are born, ask mothers what their smoking habits were and say, oh, interesting, you smoked a pack a day. Do you mind if I follow your child to the next year of their life and kind of keep tabs and see what happens? I'm not actually doing anything. I'm just observing the outcome of something, correct? Observation, I'm just observing. I'm just seeing I'm getting data just by watching versus actually doing an experiment. So an observational study observes individuals and measures variables, height, weight, etc., but does not attempt to influence the responses. Does not attempt to influence the responses. An experiment, on the other hand, that's not how you spell it. An experiment deliberately imposes some treatment on individuals to observe their responses. The difference between an experiment and an observational study. Make sense? Intuitively? Okay, section 9.2. Subjects, factors, treatments.
Wait, Professor, can you scroll back up, please?
Yeah,
Sorry, thank you.
I forgive you. Subjects, factors, treatments. You ready? Can I go? The person.
Yeah, thank
Okay,
you.
Okay. So the individuals, the individuals studied in an experiment are called the subjects of the experiment. Are called the subjects of the experiment. The explanatory variables are called the factors of the experiment. What factors cause this? What factors cause that? Is this a factor? So the explanatory variables are called the factors of the experiment. A treatment in an experiment is a condition applied to some subjects. So for example, if I'm interested in whether exercising helps you lose weight, is exercising a factor in weight loss? So I might take 100 people. These are the subjects of my experiment, and the factor that I'm investigating is exercise. And I might give these ones and these ones and these ones different treatments. You don't exercise at all. Half an hour light exercise, half an hour moderate exercise, or heavy exercise, or this or that, and so on. Okay, these are just definitions. Does that make sense? Yes, any questions so far? Seems reasonable. Yes, no, maybe so. Okay, so let's keep going. Section 3. How to experiment badly. Section 9.3. How to experiment badly. So, give me an example of how you might experiment badly. Well, one way is, what if there's so many factors that it's hard to determine which ones are really having an influence? Like if I say, okay, I wonder if exercise has a factor on weight loss, but then I have how long you exercise, what time of day you exercise, how long you, what time of day, how heavily you exercise, the type of exercise. I could be throwing in so many different options that it's hard to really determine which ones are the contributing factors. So one way, multiple factors can confound, not compound, can confound the results. Multiple factors can confound the results. So that's one bad way. Do you guys know about placebos and things of that nature? Have you ever learned about them? You guys know what a placebo is? Double-blind experiments, things like that. Anyone? So what's a placebo? Well, you say not real. Okay, I like a fake treatment better. Not real medicine. Yeah, I guess what you're trying to say. Not real medicine makes sense. And I'm okay with that. Basically, if I think I'm getting treated when I'm really not, we call it a placebo, right? Here, take this pill, you'll get better in no time, and you give me like a sugar pill or something like that. But I think it's real. It can have a psychological effect. So when the FDA does studies to determine whether or not a drug works or not, they'll often use placebos, where some people get it and others do not. Because if everyone gets it, sometimes there might be confounding effects. Okay, where you want to really differentiate between those who get it and those who don't. You guys know what a double-blind experiment is? Have you heard this term, a double-blind experiment? What's a double-blind experiment? Both don't know the, yes. In a double-blind experiment, you don't know if you're getting the real medicine or the placebo, but the person giving it to you, the doctors also don't know. Why might that be important? So why is it important that the doctors don't know? No bias. Okay, if I as a doctor know that you're getting the pill and someone else is not, I might give you a little extra more time than the other person because I know that you're actually getting the medicine. I want to treat everyone the same so I can remove any confounding factors. Not using a double-blind approach. All right, multiple factors can confound the results. Put in here. I'll do another one here. Another one is too many lurking variables. Remember what a lurking variable is? We spoke about this last time. A lurking variable. A lurking variable is what? What is a lurking variable? Anyone remember? No, it's not an outlier. A variable is not an outlier. Remember, an outlier is just one data point. A variable is something that every data point has. Every data point has a height. The outlier is going to be the weird 7-foot tall person. But the variable heights, everyone has that. So what is a lurking variable? A factor that is not really obvious. I like that one. An underlying factor, maybe it is obvious, but an underlying factor that at least is not being considered. Why do people who own more cars live longer? It's not the cars, it's the money that they have that's lurking behind the scenes. If there's too many lurking variables, it might be hard to determine what is the real reason why something's occurring. So these are all bad things to have in an experiment. Okay, does that make sense? So I don't want to do too much today because the rest of the chapter is actually a slightly different topic. But I don't want to just do 2 whole chapters. It's a lot of material. So we're going to stop here for the day. Remember, the test is Thursday. And I'll open up the homeworks for chapters 8 and 9 so you can get started either before the test or after the test. And then yeah, I'll see you guys next Tuesday. Okay.
Thank you.